Okay, in question 2 of homework 4, we're going to learn all about reserves demand. And I do it a little bit differently than other people. I have created this little simulation here that will show how the demand for reserves shifts according to various different factors. Okay, so IFF is the federal funds rate, federal funds interest rate. RT is total reserves, and you could just call it reserves, but there are two different kinds of reserves. There's excess reserves and there's required reserves. Also, you can think of reserves as being borrowed or non-borrowed. Borrowed plus non-borrowed equals total reserves. Excess reserves plus required reserves equals total reserves. So that's why I'm using a T here. And then A is the slope of this curve, and I call it the aversion to holding excess reserves. Okay, and we'll talk about that later, and we already talked about the nodes. Okay, so this right here is the shock parameter, and it's negative 29.01. I'm going to put it right here, and we're going to add to it. This right here is required reserves. This is the quantity of checkable deposits that banks have on account. And this is what the Fed says, hey, you have to hold this amount of money by law. So we got to, so 10%, right? 10% of total checkable deposits in the banking system ends up being 49.32%, or 49.32. So to the shock parameter, we're going to add the required reserves amount, 49.32. And this right here ends up being our intercept of our demand equation. Now A, the version of holding excess reserves, is 0.21. So we're going to copy and paste that right there. And we hit enter, and we get the demand curve for reserves, which is graphed right here. Okay, so let's go ahead and graph it. Whoop. Change that to black. So the y-axis is the federal funds rate, FF or federal funds interest rate. This is reserves demand, and this is the quantity of reserves. I can call it R or RT, whatever. Okay, so that's how you'd graph it. And that's the federal funds market's demand. This right here represents the aggregate demand for reserves in the banking system. So banks want to hold reserves, and they hold reserves according to this downward sloping line. Okay, so let's move on. If the propensity of banks to hold excess reserves equals 0.007, what do excess reserves equal to? Well, all we're going to do is, like we did with required reserves, we're going to multiply this excess reserves ratio by the total amount of checking account balances in the banking system. So 493.2 times the excess reserves ratio, and it was 0.007. Whoop. 0.007. So excess reserves only equals 3.45 here, and I think 2 decimal places is fine. So we'll just set it equal to 3.45. Okay. And then we already talked about required reserves, right? Required reserves are just 10% of checkable deposits. So we'll just make that 10% of checkable deposits, right, by multiplying deposit amounts by 10%. And then total reserves equals what? So let's put this right here is excess reserves. Required reserves is 49.32, and total reserves is the sum of the two, right? So 52.77. Okay. Now, if total reserves equals 52.77, right, we plug that into the demand curve to get the federal funds rate, which is going to be under 10. Okay. So we're going to use this equation up here to calculate the federal funds rate. the intercept is 20.31 minus the slope of 0.21 times the total quantity of reserves in the banking system. Okay, so the black numbers represent the parameters of the demand for reserves, and A12 is the total reserves, which is equal to 52.77. So the federal funds rate is just below 10, all right? 9.23. Okay, and again, we could add to our graph by doing this. At 52.77, which is really close to here, federal funds rate is 9.23. Okay, and this would be 52.77, and all we did was we plugged in 52.77, and what we got was 9.23, right? Okay, that's how we do that. So let's close that out. If the federal funds rate rises to 10.23, what's going to happen? So this is a little different. So now we're saying that the federal funds rate rises to 10.23. So we got to solve this equation for R, right? So I'm going to subtract 10.23 from both sides. Right? And then I'm going to add 0.21 RT to both sides. Okay, this right here is just 0, right? That's 0, correct? And so what we're left with is, let me erase this. Okay, then we subtract 20.31 and 10.23 and we get 10.08. So what we end up having here is what's going on here? Kind of froze up here. Okay, let me pause here real quick. Okay, reset and rewrote it what we have up here. So a little review. We take this 10.23, plug it into here, and then we're going to subtract it from both sides, which is why it's over here and no longer over here. Then we're going to add this to both sides, which is why 0.21 R is over here. So then, without doing any arithmetic, we can just divide that difference by 0.21 because we've divided both sides by 0.21. Right, so this ends up being 1 here. 1 times R is just R. So what does R equal? Well, it's this difference divided by 0.21. So let's go over here to Excel. I'm going to take this difference here and then divide it by the slope of 0.21. And we get 48. Okay, so if the interest rate rises to 10.23, then we get 48. Quantity of reserves equal to 48. Okay? So interest rates are rising. So that means quantity of reserves fell to 48 and the interest rate rose to 10.23. So let's close that out. So total reserves is 48. Required reserves is still 49.32. And the reason why that is because, remember, ceteris paribus, we're holding the quantity of checkable deposits constant at 493.2, and we're holding the reserve required ratio at constant at 0.1. So the required reserve is still 49.32, right? So we're holding that constant. So excess reserves, if total reserves are 48 and required reserves is 49.32, then some banks are reserve constrained because excess reserves are now less than total reserves. So some banks aren't meeting their reserve requirement, which means they have to go out and get a loan to cover the reserve requirement. So some of the banks aren't covering that reserve requirement, which is why excess reserves is negative, right? By the end of the day, all banks need to meet the reserve requirement. So they have to go out and get a loan from the Fed, or they have to go out and get a loan from other banks that have excess reserves. But since excess reserves are negative 1.32, there's probably not a lot of banks with excess reserves. So these banks that are not meeting the reserve requirement would have to probably go to the Fed and get a discount loan from the Fed. In scenario 2, we have a European financial crisis, and that causes the shock parameter to increase by 1.5 from what it was originally to that value there. This causes banks to hoard reserves, which causes the excess reserves ratio to rise. The rise in that causes Bank of Virgin holding reserves, A, to fall by 0.006 from what it was to what it is. Now we have to derive the new demand equation. The slope of it is the A parameter. The shock parameter, the new shock parameter is 27.51. And ceteris paribus, required reserves, right here, reserve requirement ratio, 10% times 493.2 is 49.32. So we're going to add to that shock parameter required reserves. We hit enter and we should get it right. And we do. So let's go ahead and take this over to Excel and calculate it. So I just pasted it in Excel. So I have the new shock parameter of negative 27.51 plus the required reserves, the reserve requirement ratio times total checkable deposits in the banking system. And that new intercept is 21.81. Okay, and you can see that the original intercept was just above 20. Now the new intercept is close to 22. The slope also got lower, so the demand curve got more elastic. Okay, let's move on to the next question. Now suppose the Fed, in addition to what already happened, decreases the required reserve ratio by that amount. So it goes from 10% to 9.1%. Now, because this creates uncertainty in the banking industry, the shock parameter shoots up 0.99 from 27.51, where it is here, or here, to negative 26.52 here. Okay. So we got a new required reserves ratio of 0.091. We're going to multiply that by the by the demand deposits that haven't changed yet. So this value. So we're taking the checkable deposits amount, multiplying by the new reserve requirement. So this becomes the new required reserves, and we're adding to that this new shock parameter. And we'll go ahead and over here and calculate it. So again, we got this new shock parameter, and we got the new required reserves level, and the new intercept is 18.3612. 18.36. The new aversion to holding reserves fell another 0.06 to 0.09. So we hit enter to see if we got it correct. And we do. So the line goes from, the demand curve goes from red to green. So the intercept of demand fell quite a bit, and it got even more elastic as a result of the Fed changing the required reserves ratio. Okay. Now, suppose there's strong economic growth, and that causes checkable deposits to increase by $24.9 billion from what it was to 518.1. Okay. So all we're going to do here is we're going to go to the green intercept of 18.3612, right? All we have to do is change the checkable deposits to 518.1. And we get a new intercept of 20.63. So as paribus, the slope is still 0.09. Slope of reserves demand is still 0.09. So we had to enter to see if we got it right, and we should. Okay. So it's almost like it's a parallel shift, right? So the Fed's action pushes the demand curve down to green. Surprising economic growth swells demand deposits, which increases the intercept. But since we're holding everything else constant, we have a parallel shift out to blue. Okay. And then this data project down here, you can do that on your own. Just follow the instructions very carefully. One last thing, let's label one of these graphs. Give you an example of what I'm looking for. The federal funds rate is the price of reserves, bank reserves. R is the total amount of reserves. The green line is reserves demand in scenario 3. The blue line is reserves demand in scenario 4. Okay, and that's kind of what I'm looking for. Close. And that's it for reserves demand.